weekly contest 367. The problem is, this is the fourth problem, like the last problem, construct product matrix. In this, what you haven't given, you haven't given an initial grid. What you want to return, you want to return a product matrix. What is a product matrix? Product matrix is again a grid of size n cross m, same, but the each element is special in a way that it is equal to the product of the complete grid divided by the that element. And obviously this is all happening with a modulo this mod, which is 1 2 3 4 5, product of all element except the element. So basically, yeah, you can say product of all element except the element. So everything other than just 1 is 24, so that's why 24 is written. Everything other than 2, it's 12, that's why 12 is here. Everything other than 3, it's like 4 into 2 into 1, that's like there. Okay, how do I get this now? So the way we have to do this is, you know let's say I want to know the every product of every element, just except 3. So I want to know all the rows above it, all the product of all the rows above it, all the rows down from it, all the product of all the rows down from it, and the current row element, prefix except 3, suffix after 3. That much information if I get, I can get the answer for 3. Why I did not something said like something like this: key do the product of complete grid and divide by that element in the modular terms. Modular inverse is there, but why mod inverse when we use that power function and yeah, x raised to the power p minus 2 kind of thing? That is only done when modulus is non-prime. But here 1 2 3 4 5 is a prime number, not a prime number. Yeah, we do that only if the modulus is prime. Like 1 9 plus 7 generally is right in CB, but over here it's a prime non-prime number. So for this we cannot do the same formula, like for modular inverse. Or if you try to find modular inverse by linear search, that's gonna take so long time, and yeah, that's not basically, yeah, exceed the time complexity. And the next thing which you got now is prefix and suffix. That's what it is. So again, I'm repeating. For example, let's say you are standing on the first row. I call it first or second row. You can call it second row, but yeah, zero indexing, but yeah, still second row. First element, which is 3. So what will be the answer for 3? I see. Okay, I'm standing on second row. I need a prefix sum of everything before row 2. So like for row 0, row 1, yeah, there's only one row, right? But there can be something, so many rows. So prefix of that, suffix of that, and the current row element. So that's what we need, a prefix and suffix of the rows and the current row thing. So this is how I get the prefix of all the rows above it. So we use this form like for I0 to n, p is equal to 1. For each column we get this prefix of the current column, and pf of I is equal to pf of I minus 1 into the current row, right? And this is just modulo multiplication. Also, if the row is like first row, you got just the p itself, so this should be 1. And this is for suffix, like for each suffix we got p, and then for the current row, and then s of I is equal to suffix of I plus 1 into this p. That's how we got prefix and suffix rows. Now all you need is the current row for basically, yeah, like everything, let's say above it, everything down from it. But when you are going for a particular element, you know that this element lies in this row. All the above rows I can take, all the suffix row I can take using this, but what about the current row? I cannot include it completely, and so I need to include it like prefix of it and suffix of it. So I'm going for current row, and this j is the current element. I need the prefix product, which is everything before j. So this gives me that key pf getting multiplied by the current element every time. So pf started off from 1, and this has got me pf, and if ij is equal to prefix of I minus 1, everything above it, everything below from it, and this is the current thing. Where is the current thing? This is into pf, this is the current thing. So you got prefix fine. Now you only need to add suffix to it. So a of ij will become a of ij into suffix. So suffix is, yeah, you are reversing for from last element, to 0, and then suffix is getting multiplied each time, and every time you are multiplying it with suffix, and at last you took everything into zz. Okay, zz was not required over here, you can just completely delete it, and a kohi we can write int. I think that should pass everything. Like, you should take long carefully integer overflow, like this p can integer overflow, pfn suffix obviously integer overflow, and then this pff and this ff sff can go integer overflow, and code submit it. Compilation error, yeah, what was the issue? Zz return zz की जगह return है. That's it. Okay, accepted. So this was the whole problem, like four problem. Nice. Okay.